Good morning, everyone, and welcome to today's session titled Awesome Technologies Spurred by the Pandemic. Without further ado, let me give the floor to our speaker for today, Mr. Joel Mendoza.
Good morning, and it's good to see you around. Although I don't get to really see you a bit virtually. So this morning, I'm going to talk about a, a topic which is, I would say, um, um, a bit relevant now that we're all stuck in our own respective homes. And okay, this is a topic, awesome technology spurred by the pandemic. Let me just stay out of the way here. Okay. um, so um, initially, what I had in mind was to give you some sort of like a survey of all of these awesome technologies that have been sprouting about since we were all stuck in our own respective homes. And I was wondering, maybe there's because there's really a lot. So I just decided I'll just focus on a couple of things. And since this is something to do also with a bit of research interest, so I wanted to focus on a couple of technologies. And I hope you won't mind, instead of covering a lot of areas. So you can have a lot of field areas actually, like, for example, in the field of medicine, in the field of transportation and stuff like that. But I just focus on a couple of them that are IT related. Why? You'll see in a while that that's because we're very much exposed to it. Okay. So to start with, if you notice here, um, you have some sort of like a spur. I'm using like a. This is actually a spur, the thing that they put on their boots. The cowboys would put on their boots to to spur the how do you call this, the horses. So technologies actually um, are somehow pushed in the wake of a number of things. So, okay, there's this saying which somehow goes like this: necessity is the mother of all inventions. Okay, so um, I don't know who really started that. I mean, who made that original saying. Some attributed it to Plato because of some, I don't know, a wrong translation. But then what happens actually is that when there is a necessity, then so many things are pushed forward. Okay, like for example, the radar. This is in at the beginning of the Second World War. So the Brits started using it to to detect aerial aggressors. This is in the early days of the Second World War, but of course after the war, so there was this need, because there's this need to really defend one's home country. So they deploy the radar technology, and then of course after that you have some other offshoots. Now it's being used in for civilian purposes, and then of course the one popular offshoot of the radar is a microwave oven. Okay, which we find in every domestic kitchen. Okay, of course another thing is the rocket. Like close to the end of the Second World War, you see the Allies started coming in from different fronts, the East and the West, and they were actually in a race, not just to annihilate the Nazi army, but then also to grab the spoils of war. And one of them is the most prized of which is the V2 rocket technology, okay, which the German scientists were had been pushing. And of course, after that, well, because of that, they were able to, the Allies were able to get the technology. And then you have the space exploration projects conducted by NASA and also by the CCCP or USSR at that time. Of course, you're familiar with the Sputnik. This is also the height of the Cold War. When Sputnik was launched by the Russians, the Americans responded, they say, with, of course, the Department of Defense with the ARPANET, and then which well, you already have the internet. So what's my point here? So there's this need. The need is in times of war. So there's a sense of urgency. So you really have to push technology to its boundaries, and then you get that you squeeze out all your resources until you come up with something. Okay, but then there's this. Some said, okay, there's this English philosopher, mathematician with the name of Alfred Whitehead, and said, no, it's not really necessity, but rather science. And he argues that the basis of invention is actually a science. Well, you can see probably it's true, but then necessity somehow pushes science, which might be just dragging its feet if not for the necessity. So we're not in a state of war, fortunately, but you can say somehow during this COVID or this pandemic year, we are somehow exposed to this urgency, this necessity, and somehow science has to be prodded to push a number of things. Okay, so it's been when that's March 2020, it's close to 8 months. March 22, precisely when Pierre, when I think when, or March 16, when they called off classes and stuff like that. Okay, so this is the ExfromHome, sorry, the ExfromHome season. So we do everything from home. So work, entertainment, study, and stuff like that. I'll just show you a couple of graphs here. So what do you find here? So we're looking to connect and entertain ourselves, but turning away from our phones. So what's actually happening here? So here you have websites and then apps. Before, people were using apps, like for example, Facebook, they were running Facebook on apps, Netflix on apps. That means using mobile devices like your phones or your tablets. But then what happened here, as you can see, is that somehow there was the apps use was somehow went down, as you can see here with YouTube, and what rose are the usage in the websites. Where do you use the website, or where do you use, what platform do you normally use for the websites? Well, you use your desktop computer, your laptops. Okay, so this explains actually, if you might wonder, how come people are using the websites more than the apps? So as you can see here, the rise, precisely because we're turning away from our phones, because phones has something to do with mobility when we travel. Since we no longer travel, since we're no longer in our places, remote or outside of our homes, we're just stuck in our homes, and we have we just have recourse to our desktop or laptops. Okay, so that's an interesting fact, and that explains all of these changes. Another area here is, for example, video games and online entertainment have been gaining while sports have lost out. Of course, that's pretty understandable. They canceled all the games, so no one's interested in watching games, or no one's watching games. But of course, Twitch, which is, by the way, if you're not aware of Twitch, is a live streaming for gamers. And then of course, TikTok, I suppose a number of you have TikTok, so they really rose. Okay, this is from January, and then goes up all the way. And you can see by the moment the pandemic was announced by the World Health Organization, it just shut up. Okay. What else can we see here? We have suddenly become reliant on services that allow us to work and learn from home. Now, of course, the main beneficiary rather of all of these is Zoom. As you can see here, just skyrocketed after mid-March. Everyone was before Zoom. I suppose none of you knows about Zoom or what it really is as an app or as a software. But all of a sudden, people were using Zoom. And in the area of education, of course, you have the Google Classroom, and practically almost every um, um, school has been using it. And then, of course, you have Microsoft Teams, so on and so forth. So what am I getting at? Is just to give you a little bit of a background there, a picture on what is going on. Um, so with that, let's see. We have been using all of these platforms, particularly the web conferencing platforms, because it's like the hub of we've been doing. So there's this ad from Google Meet. It says, meetings are no longer meetings. So what does it say before? Because they designed these, for example, Google Meet or Zoom, they were designed basically for meetings, um, for web conferences, remote meetings. But all of a sudden, so people have started using it in the wake of the pandemic. People have started using it for other things. So for working out, exercises, celebrating together, collaboration and stuff like that. So again, the video conferencing platform has changed, has evolved into something else. So there you have it. You have some sort of like a need, a necessity that somehow the pandemic has spurred, and that's jolted, and then somehow the service providers would have to catch up. They don't know, I mean, what can we do? Because people are using it in ways that we have never imagined them to be used. Okay, so you're all familiar with this scene, of course, not with these faces, probably be looking at a different set of faces. But this is a typical Zoom or Google Meet, or I don't know, whatever platform you're using. So there's this like some sort of phenomenon. People have been using these web conferencing platforms. So if you're exposed to this sort of thing, just imagine, okay, hour after hour after hour. So I suppose you know what happens there. There's this phenomenon which we call the Zoom fatigue. You're just sick and tired of how things are. I don't know, because I hear some of my colleagues have been saying, I've been looking at the computer, looking at faces every day, day out. So I'm just sick and tired because, of course, we have to meet for professional reasons, for social reasons. So practically, this is what you've been doing. So here's a challenge, or rather some sort of a problem with all of these platforms try to solve something, but then you end up with these fatigues. So there's like some sort of like a side effect. How do you decrease the amount of visual noise? As you can see here in my example, I mean, imagine you're talking to, let's say, a group in the physical realm. Normally it's a lot easier because let's say you're in a round table and then you have more or less similar background. There's a continuity of a background, but here you have people with different backgrounds. I mean, literally you can see that this one is inside the living room, this one is in a sofa, or we have the kitchen behind her and stuff like that. So it's pretty difficult. Okay, so how do you deal with that? So you have just a lot of visual noise, and psychologists and sociologists have been also looking at this thing of what you call the Zoom fatigue. So how do you decrease the amount of visual noise? Now, this is where the technology comes in. Of course, there are a lot of technologies behind Zoom and all of these video conferencing platforms. But I'd like to take a look at this. So here are some of the approaches. So for example, Zoom, you're already familiar with this, and probably you've been doing this a lot, changing the background, the virtual background. This seems pretty straightforward, but actually there's one thing that I'd like to talk about, changing virtual background. I would say it's one of those awesome technologies. You might think well, that's really a no-brainer. It's not rocket science, but actually there's a lot of complexity behind this. So we're going to look at how these people solve the problems. But first of all, before I get into that, what's happening here is that, okay, is this really, maybe you're just adding visual noise because of these backgrounds. Actually, if, for example, you have, let's say, a common event and everyone would have the same uniform background, for example, a birthday party, and then everyone had the same background, then that would really help in relieving the Zoom fatigue. So that's Zoom's approach. Google Meet came up with another approach to somehow eliminate the visual noise, and that's with the blur effect, as you can see here. So the blur effect, you notice, is not as clear. So there's the focus is on the individual. Okay, everything else is clear except for the background. So somehow it also helps in focusing when you're conversing with someone. At least you get to look at the person in the eye or the individual itself, rather than look around and get lost in the conversation, so to speak. Okay, and then, well, there's another interesting take. Microsoft Teams made an extra step to solve this, and they came up with this feature called the together mode. So they crop, everything is done automatically. So they crop out the silhouettes of the individuals, and then put them all there in the same background, but not just in the same background, but in the same virtual environment. So, which makes things more natural. So this is one way that Microsoft's answer to removing this thing called the Zoom fatigue. Okay, so with all of these implementations, actually, what are the different approaches to getting rid of the background or the visual noise? How do you really decrease visual noise? The problem seems to be pretty simple, and it's somehow like this. You get the foreground and then also the background. So you determine which is the foreground and which is the background. You're dealing here with how do you call this, with moving image, a video. So this one is constantly changing. So that's quite a challenge. Okay, so it seems like an easy problem. So there's a lot of computational work done here, but since I know you're not, all of you are not into IT, we're not really getting into the technical stuff. So let me just show you here more or less how the problem is, the different approaches in solving the problem. This looks a bit overwhelming, but don't worry, this is the compositing equation. Let's just, in layman's terms, let's look at it this way. This is the pixels, for example, this is your C for the capture image. This is what you want to come up with. And this is the alpha, which is the transparency of this. Let's say this is your original image. Okay, and what you want to do is just to extract this, just this portion, the foreground. F is your foreground, alpha is the transparency, and so the white section here is just is what is visible. The black section is just masked out, and then of course the 1 minus alpha, the reverse of this, and then multiplied by the background. Presuming you have this virtual background, this is the original background, and you want instead to use the virtual background, then this is the formula. So it looks pretty straightforward, but this is the problem that the people have been trying to solve, at least in the computational science. Okay, so like I said, we'll approach this in a layman's, from a layman's perspective, and we will not really get into much details, the mathematics behind it. This is the most mathematical that we could get, at least for this presentation. But it's composed, the final image, or let's say the video, like imagine the Zoom background. It could even be the Google Meet together mode. Instead of the captive background, you have the they call this the chair or the sofa or what have you. Okay, and then you just need the foreground and the background. So the problem really is, what is the foreground and which is the background? Now let's take a look at some of the techniques that have been employed. One is chroma keying. I don't know if you're familiar with chroma keying. Chroma has something to do with colors, and keying is just to mark something. And this is done in Hollywood. Well, the movie industry loves doing this. For example, so they make use of what you call the green screens or the blue screens. Normally it's either green or blue. So they shoot the characters with the green screen behind them. Also, as you can see here, the flooring and then the wall. And then afterwards, once they have so that isolates the foreground, and then they just replace it with the background. Okay, you may wonder why green screen, why not red screen or pink screen? I prefer a pink screen, for example, if you're a fan of pink. But then green screen, that's because green, and if you look at, take a look here at the chroma spectrum, red, orange, yellow, green, blue, indigo, violet. No, sorry, it goes back here to red, to the rainbow colors. The color of the human skin is actually falls under, has these tones of red, orange, yellow, pink, and a little bit of brown and stuff like that. And of course, it depends. If you're a black guy, this guy is totally black. He's wearing a mask, but he's supposed to be black. Here's a black one. Okay, so but you have those same tones. Okay, so what's the point here? So green and blue are the farthest from the human tones. So that's why they use green and blue, so as not to introduce noise. If you take note here, his hand has been covered with a green material also, so they could use a CGI effects on this. But that's one technique, chroma keying. So that's what the Hollywood would use to remove, to identify the foreground, and then just to easily remove the background. But come to think of it, if you're using Zoom, you don't have to buy. I mean, we don't have green screens. You can actually buy green screens in Lazada or Shopee nowadays if you want some of these green screen effects, and then you can put it at the back of your chair, so you'll always have that green screen. So with that, this makes you come up with a good segmentation of foreground and background, because what the computer does, or what the algorithm does, is just to find anything that is green and then replace it with the background, whatever background image you have. So anything that's green, so if you have something that's green here, like for example, this arm is green, automatically the background will be changed. But in this case, they replace it with a computer generated image. Okay, so that's one technique that they employing. Is called chroma keying. But that's not applicable in our case, like for the case of Zoom. Another approach that we could take a look at is facial recognition. I mean, this is something already pretty common. We already have algorithms that can identify faces just by looking at these patterns. So, for example, you can already identify what are the eyes, the nose, and then the mouth, and then of course the eyelashes. And with that, more or less, you get the profile compared with the contrast here with the background. And more or less, you can already define in real-time faces. In fact, you have a number of applications with that. So here, this is gonna done in real time. It's able to detect your face in real time. It knows when you're going side view or front view, and this is how the more or less the sorry the this is how the algorithm works. Of course, it's deep learning. They make use of advanced neural networks for this. That means they need to train the machine, the AI, to train the machine with a lot of data sets of different faces, faces of Chinese, faces of Africans, faces of Caucasians, so on and so forth, and faces of people of different age and gender. And then with that, so it's like, just come to think of it, it's somehow like if you imagine you're training a dog, and the dog, you're teaching the dog which actions are good and which actions are bad. If the dog's dog or spank the dog. If the dog does something good, then you reward it with I don't know, food. Now, somehow the dog learns in the process. Okay, this is what I'm doing is good because I get rewarded. And then somehow with that sort of training the dog is the same thing also with machine learning. You're training with a lot of data sets. That means a lot of inputs, and then you come up with the model. More or less, the dog, going back to the analogy of the dog will say, I can do this, but this one I won't because I'm going to get hurt in the process. Okay, here's another concrete application that they have. This time they really get the features of the faces, the contours, and what's beautiful about this is they can do some what you call augmented reality augmentation. So you can add caps and whatever virtual objects you have, and the objects would also change uh, their orientation and then even the scale based on that input, which is your facial features. So the question is, does Zoom, is this applicable for our case? Of course, you can more or less already detect the individual, and from there, you can figure out more or less. It gives you a cue on the foreground, which is the foreground and which is the background. Here's another technique that's pretty popular. It's called difference matting. So what is difference matting? You see here, objects here that are moving are being detected. Okay, so here you can see which is the foreground or which are moving and which are not moving. Now, if you have this model, if you're able to you only see here some boundary boxes. So with that, you can already, this is done in real time. So the computer detects this. So that means with this algorithm, you can say this is a background and this is the foreground. But what can you say that these people here are also foregrounds and these are also foregrounds? Aren't they also supposed to be backgrounds? Let's say you're here. Let's say imagine you're talking to someone and someone walks behind. So is that person, that individual, your mom or your sister, kid sister walking behind you? Is it going to be considered as a foreground or a background? So those are some of the challenges. Okay, but those things, these are the algorithms that are pretty interesting that are being used. Okay, and another, and this is the last one here. We call this image detection, or rather edge detection. So you're able to determine just by you have here a real image, and your algorithm is able to determine the edges. So how do you do that? Of course, your cues are color and then the sharp adjustment. As you can see, boundaries. How do you know a thing is a boundary? That's because there's the intensity. There's a change, a sharp adjustment or change in the intensity. So for example, if this is purple or pink, and then all of a sudden you have green, then there's a sharp change adjustment intensity. You can identify this is a boundary. Of course, another way to figure out which is an edge is we compare textures. This one has a different texture compared to this one here, and then you're able to figure out what the edge is. So that's one very concrete. This one happens in real time, by the way. There's another. approach, which is object detection. So you train, for example, your 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 AI to, for example, detect the ball, and then from there you could even see the motion pattern of the ball. Okay, and then so you can do that with faces, glasses, and stuff like that. So here, this is quite a challenge because in the case of for us human beings, we're not really how do we detect foreground from the background? Well, we humans, since we understand what a ball is, what a human is, then we can say, for example, this blackboard cannot be a foreground. First of all, because you have some of these cues. Like, for example, this guy here is moving, and this blackboard, I mean blackboard, and this is where understanding comes in. So just by using semantics, you'll just, so background, the blackboard is always at the background, so it cannot be in the foreground. And you understand somehow what the person is with eyes, nose, ears, and a head, and a couple of a pair of arms and hands. So you would say, okay, that is a person. Computers do not have that sense of abstraction, of understanding what a human is, or what a blackboard is. So somehow you have to train it in a different way. So those are some of the challenges. You can see artificial intelligence is actually basically artificial. It won't really be able to cope with what humans can capture, because we humans have, I mean, that sense of abstraction, that we can really know things as they are and even grasp abstract concepts, and computers could not do that. So those are the limitations. Okay. So with that, okay, so the question is, what is Zoom and Google Meet and Microsoft Teams? What are they using? Actually, I tried to look around. I wasn't able to figure out the answer. But you have a couple of, I mean, a lot of papers and research work talking about, even the most recent one that I've been reading on 2020, background mapping, from people in University of Washington. You have some of those video background subtraction in complex environments, some of those seminal papers and research work, which somehow contributed to this. So I would say Google, Zoom, they're using a mixture of all of these, but of course, they introduce a lot of machine learning, and actually not just machine learning, but deep learning systems, deploy deep learning systems just to come up with these. Okay. Another thing is noise detection. Okay, this will be the last one I'm going to, I think I'm overshooting. So how do you decrease the amount of auditory noise? So let's see if you can, here's a guy, he's one of the employees of Google Meet, one of the researchers in Google Meet. So here
are people that eat.
So you can hear the crinkling sound of the wrapper,
or eating cereal,
the glass
yes,
noise.
Sweden.
And now turn on the noise cancellation.
I can talk at the same time, and it will be removing the crumpling from my voice.
So you don't hear the crumpling, but you can still hear his
Allen
voice.
Key glass demo here.
And the noise has been canceled as well.
And
okay, so those are so that's more or less the technology. We think, oh, that's pretty cool, but I would say it's pretty awesome. Okay, so noise cancellation. So it's quite a challenge because for us humans, how do you really approach this problem? So the human vocal frequency is actually, okay, first of all, how do you then identify which is the foreground and the background sound? What is noise in the first place? How do you define noise? People say, okay, noise is actually something that is unwanted. So for example, if I talk right now and let's say I breathe or inhale, exhale, is that also considered as a noise? And what is noise actually? How about singing and stuff like that? Or if I play the guitar and sing, so will the guitar sound be subtracted from the noise? So these are some of the challenges. So here you have the human vocal frequencies. So of course, you have lots of studies related to this. Of course, the female voice, the adult female voice, is an octave higher. And yeah, I forgot to add the additional figure here for children. Of course, it's higher frequency, but with that, you're somehow given an input. Okay, that's the vocal range of humans. So somehow it gives you an idea of what is the foreground voice. Okay, so so if you have a background noise, for example, like I don't know, like the cock, the rooster crowing in the background, the the vacuum cleaner, or I don't know, the doorbell in the background. So you can always remove it. Okay, so another one approach that they also do is what you call the dual input mode. So you have a microphone. So you have two microphones actually. One microphone here, which will pick up the vocals, and of course the ambient noise or the background noise. Now this other microphone doesn't only picks up the ambient noise. It's focused somewhere else. So what it tries to do is, given these two inputs, you're able to figure out, okay, given this is your background noise, the unwanted noise, the noise, whereas this one also has some noise, but what you do here is, given this input, you reverse it and then add it to this input, and then you end up canceling out the background noise. Of course, that's pretty. So the question is, how do you do that? I only have one microphone in my computer or laptop. Actually, you have some. As far as I know, Google Pixel try to deploy that in their devices, which, so you have two microphones, one which is close to your mouth and one which picks out the outside ambient noise. So that's another approach of figuring out the foreground from the background. Okay, but this is what Google Meet, Google does. Actually, this is, you just consider this area here as a something in the cloud. It's a base running on TensorFlow. So basically, you have the input. First, they come up with lots of data sets of voices, human voices, and that also includes inputs with noise and stuff like that. And so they train the AI, and such that they have lots of, they come up with a model. Again, going back to the example of the dog, training your dog. Somehow your dog sifts through all the information. Is this good or is this bad? Now, if the person is rather inconsistent, you spank the dog because he was being nice to you, then the dog would get confused. Oh, wait, I thought that was a nice thing. I thought I'm going to get rewarded with this act. So that's the thing. So you always get that noise, and somehow your model, as the training continue, as you have more data sets, actually 60-80% of all the data that you've gathered, you input it to train your AI. Then you come up with a model, and this model somehow will be what will be used. And then you have your input data. So for example, the actual thing, which is just 20% of your information, it should also be a test for validation. And then the machine learning algorithm applies that model. You would say, okay, is this noise? Is this the wanted sound? Is this the unwanted sound? And it predicts, of course, it makes an evaluation, so on and so forth. And it just feeds it there. Okay, so those are, of course, that's all in running in AI. But that's the thing. So what happens here is that you have a lot of mixed data sets, and it trains everything from noise and clean speech. So basically, the audio of the speaker is sent securely to the cloud using machine learning algorithm, analyzing it, then detecting the main voice and removing all the ambient noises surrounding in real time. And then, of course, this comes out here once the processing takes place. You have the filtered out voice, which is free from the ambient noise, and it is delivered to the person on the other end of the call. so your friend is listening to you. Of course, the process here would somehow degrade a bit of the voice quality. So it won't be exactly the same voice as you have here, and you have a number of limitations. That's quite a challenge because you need to train a lot more, and so they really have to do a lot of inputs here, and of course they have to figure out, for example, they have to introduce a lot of controls as well. Okay, so with that, let me just close here. I've been sorry, it's taking longer. So they say science is the mother of all inventions. I would say, okay, aside from science, let's say fatigue also could be, well, not necessarily the mother of all inventions, but somehow could spur us to push things, push technology, the boundaries. Okay, so that's it. Thank you very much for listening. And that's all that I have to say.
Okay, so the floor is now open for questions. So please use the Q&A section found below for any questions, and Mr. Joel Mendoza will gladly respond. Okay, Sir Joel, there's already one question. You talked about Zoom fatigue. Is there such a thing as online class fatigue? If so, what are the remedies available that individuals and schools can use?
Online class fatigue. Yes, definitely. I think there's an online class fatigue. I mean, anything that's when you do things online, because there are a lot of factors actually. Even not just, well, even for teachers who are teaching, or even those people giving webinars, it's because I mean, you have some of these social cues that are already missing. You know, when we talk, for example, we look at each other face to face, and sometimes when we talk, for example, in my case, I would look at my camera. My camera is here, and then but I have my stuff here. So you might be wondering how I'm looking at this direction when you're supposed to talk to me. So you have some of these social cues that are missing in an online environment. And somehow the human brain who has been wired I mean, with conversations, with eye contact and stuff like that, all of a sudden our human brain gets burned out because what's going on here? He's not looking at me, but he's talking to me, or I don't know what he's doing and stuff like that. So this fatigue, and of course the classes, there's no, for example, in a normal class, this normally happens. Sorry, teacher. Okay, I asked the students, "How are you doing?" And then anyone could just answer, "Yeah, sir, we're fine," or not, we're busy and stuff like that. But then in a Zoom environment or Google Meet, you hardly hear an answer. Sometimes people would hesitate because there's no such thing as a whisper in these platforms. So sometimes in a normal classroom, I could whisper to my seatmate and say, could you grab me, kunin mo to, or pakikopya naman ito. But in Zoom, there's no whisper. When you talk, everyone talks. Of course, you have some of these chats and stuff like that. But then it's not as natural as things are. So it's always broadcast mode when you talk to someone, or when you start talking in Zoom, it's always broadcast mode. There's no unicast as we have in, for example, in a normal classroom environment. I could talk to this classmate of mine, or I could just talk to one student, "Hey, how are you doing?" And then disregard the rest of the class. But in Zoom, you always have broadcast mode. That's why I'm a bit hesitant or students are a bit hesitant in talking, because it's always broadcast. So those are some of the natural communication and social cues that have been missing, have been lost. Okay, and so online class fatigue is there. So what are the remedies available? Actually, well, some of the technologies that people have been trying to, there's a lot of studies going on with Microsoft, which has been introducing a lot of things. For example, what Google has been trying to do is adjusting the eyes. Sorry, this is Microsoft, adjusting the eyes so that it would always look at the front. So for example, right now you can see where I'm looking at. Okay, maybe you're not seeing me clearly here, but okay, I'm looking to my right. I don't know if it's to your right or your left. But then what Microsoft Team does is you will always be looking to they always autocorrect your eyeballs so that it was look in front of you so that you get those social cues and stuff like that. So you can approach it you have some solutions using technological approaches, but we still don't know. And even, I don't know, remedies, because it's a lot. It's not just an approach, it's a technological approach. It's a social thing. So I don't know if I answered your question. Did I answer your question, Mr. or Miss Anonymous Attendee? Okay, so do I read the rest of the questions?
Oh, sir. Okay. For the next question, how can we use technology for physical heavy classes like ROTC and PE? Or are these technologies only beneficial for geeky subjects?
Actually, you have a number of people have been trying out a lot of things. They say you can really do things online. But again, so physical heavy classes. So you can't really replicate them. I would say they can't. It's really difficult to replicate them because, for example, team games like, for example, basketball. It's not just a matter of knowing the individual skills, like handling the ball, this and that. You also have to know, for example, where this person comes in. If this is the opponent, what should I do? Should I make a second guess? If this guy comes, is he going to block me? Should I shoot or should I pass? And these are the things that you cannot simulate in a remote environment. Of course, you have some games that could simulate them, but you cannot mix in the physical things. Now, probably some aspects so you have what you call virtual and augmented reality. I know there's this video on a bike, um, biking, so people get to do social. They can ride the bike, and then there's this video. You can use a large video, and then you can do bike with other people. You can change the environment, and then as you bike, you also get to feel the friction and then the elevation and stuff like that. So one of the approaches probably for technology is to push further the VR or virtual reality and augmented reality technologies. So let's say you can play basketball and do the physical stuff using those motion detector sensors that you have at home. And as you play basketball, you can shoot or pass the ball, and using more or less the same algorithms as you have with those let's say NBA gaming platforms. So this time you get to do some physical stuff. So that's the approach that I can see, but it's pretty difficult for now. And of course, it's going to be bandwidth intensive. So you really need it. So you imagine you're going to input a lot of things, what the other person are doing on the other end of the line, if they're shooting, handling the ball, if they're running. And of course, you have the vision. So you have to have more or less like a 360-degree vision. So you need to have some VR glasses for that. And you've seen some movies that get to do with those things. So probably that's one thing that I have in mind. If it's going to be a solution or an approach to solving this. But of course, the pandemic won't last that long. So most likely we'll be going back to our physical meetings. Yeah, I hope that answers your question.
Okay, next question. Nice overview of the adoption of technology during this pandemic. Do you think this adoption is only temporary, for example, during the pandemic only, or more permanent? If more permanent, what old habit will no longer be happening?
Okay. Oh, okay, great. It's a good question. Actually, I've been thinking about that as well. The thing here is, we won't, as what everyone else is saying, and as many articles are saying, we won't really get back to that old normal. It will be a new normal. Okay. And then things have worked. For example, I've been talking to some of my colleagues, professionals, and they're saying, wow, I've never had meetings that are so productive. I'm able to do a lot more than before, because before when they go to the meetings, this guy is a real estate broker, so he goes from one place to another, and of course with the traffic and everything, he only gets to spend one meeting in the morning and another meeting in the afternoon because all the travel and stuff like that. And of course, there goes also with eating. They have to go and order the food for the in the meeting, and that will mean waiting time and stuff like that. Because now there's no need to order food. There's no need to travel, but I'm able to come up with attend 4 meetings in one morning, and I've never been so productive. You see, you have some advantages, and because of the pandemic, somehow the technology and the capabilities of individuals have been pushed, and somehow people have started learning how to use these technologies and adapting these technologies. So some of them could be retained. So I would guess, for example, all of these things in the webinars can be there, uh, and of course people will still want to do some physical meetings. But then somehow even with classes, I would say some will have to be retained. So in fact, this thing of the blended learning environment, the idea of blended learning is not just fully entirely 100% online, but there will have to be some sessions where you get to meet and you can do a lot of things. But those other things, like for example lectures, don't have to be physically done. In fact, there's a new, some sort of a different model right now in delivering classes. So as the saying goes, the sage on the stage is no longer there. So someone just talking there and the people just listening passively. And now the learning and education has shifted more into someone who's guiding. So the professor is not just someone who just talks, and then the student listens, and take notes, then just get to feed which is the right answer and the wrong answer. It's a different approach to learning. So it's the student stays in the forefront, and it's more of an active learning approach. I learn as I do things, as I try things out. And then the teacher, the professor is just there as a guide rather than someone who just keeps on pointing, do this, don't do that, don't do this, don't do that, and stuff like that. So these are some of the models which we can adopt, and somehow it tweaks our systems. And you can say um, a lot of things will be retained. And so those old, as you hear, those things that worked during the pandemic and with people like will remain. Yeah, I hope that I answered the question.
Okay, for the next question, I like the green screen concept you shared with the movement to more online classes. Does it make sense to spend for stuff involving the green screen?
Yes, I've seen enough. Thanks for the question. I've seen a number of universities, actually, in the university where I was studying before. At that time, of course, that was more than a decade ago. At that time, they already had classrooms, well, not really classrooms, studios with green screen. So they were really prepared for online learning. So teachers, in fact, I've seen recently Harvard having studios, converting their classrooms and their lecture halls into studios with green screens around them. And then so the teacher could walk around and the students could see the teacher. And then it's what's even more exciting is that things are more um, um, let's say even so enhancing, because there's this immersive effect. So the teacher walks around, and then this background, which is like something like a 360-degree view, or more or less 180-degree view, is the screen, and then with all the text and the animations and stuff like that. So it's very, very much enhanced. So it could be something that, for example, I don't know, university could invest in, let's say a green screen studio, probably when the quarantine would be relaxed, and then people could already start going to work. So, and more classes can still continue to be online, and because of the blended learning approach, and probably the green screen could still be pushed further. Um, yes, it makes sense to spend more stuff on it. I hope I answered your question.
For the next question, have we seen moral issues with the use of technologies during the pandemic? How should we prepare ourselves with those situations?
Moral issues. Well, here, for example, when people, for example, do this, okay, let me just share this. Okay, this one here. When some of the moral issues are, for example, data privacy, because, for example, what people found out that IBM was using lots of data. They just picked them out from the internet. Okay, they used lots of data to capture images from around the entire World Wide Web. Um, so it's big data, and they started using it to train their AI models. Okay, and people were asking, oh, does Microsoft, or rather, does IBM, did their privacy rights? In fact, when National Geographic learned that IBM was getting all the pictures from National Geographic and feeding them into their machine learning algorithm, so that they can determine, for example, different faces and stuff like that. So they complain and stuff like that. So in fact, it's because it's easy to grab videos nowadays. You just go to TikTok. All of these videos are available for free. YouTube, you can scour YouTube and then grab all those videos of faces of people, and then you can use it. Probably can say, okay, it's good to have, because in order to train better, you need to have a large data set. So the more data set you have, now then the better trained your model will be. So that's one issue. So the privacy issue, it's good to do that. In fact, some other things like virtual reality. I don't know if you're familiar with the deep, of course, with deep learning, and then people can even change in real time faces. For example, if I have the face of Trump, Donald Trump, in different angles. I already keep that in my library and then use it and superimpose it on another video, and then I would
Es ist
make
12
use
Uhr.
of Trump's voice, and then come up with everything done in real time with fake pronouncements. Then so these are some of the issues that I've been seeing nowadays. So privacy, and then of course with all of these fake news and fake representations. How should we prepare ourselves? I don't know how to. Well, we come up with, of course, these policies. Like, for example, the Data Privacy Act and the GDPR. They came up because of complaints of people. So maybe probably the lawmakers, and of course, we try to push for these laws to be pushed. I hope that answers your question.
Okay, next question. Amazing concepts. I didn't know there are a lot of more complex stuff about videos and AL. Are we doing anything? Are we doing anything in these areas in UANP?
Well, as far as I know, we're not doing anything. um, but actually, I myself, this is my research interest, where I did something like this before while I was doing my master's. But I'd like to jump into this, especially digital signal processing, VR, AR, and then also, of course, computer vision and stuff like that. Because first of all, you have a lot of, for example, I talked to you about TensorFlow, and you have lots of open source libraries. You can even download codes and stuff like that. So if you want to experiment with it, and you can even further develop the code, and then you can come up with additional research. So you have lots of materials out there. So it's very, very much possible, but we're not doing it as of the moment in UANP. Okay, I hope you answer your question. I answered your question.
Next question. Are there any Filipino language-based datasets for training an ML model?
I'm not aware of that, but you can actually, like I said, you can actually nowadays with the internet, you can actually extract a lot of data. Just go to YouTube, for example. Actually, YouTube is one of the most favored source of data sets. And of course, Google and some of those social media platforms. But at least for videos, YouTube has a lot of them. Just download, for example, look for those people speaking Tagalog, just extract their voices, and they can use the data sets. Of course, you need to do some bit of filtering, a lot of work, but then you can actually come up with them. But I don't know of any active involvement as regards Filipino language-based data sets. Google, I know I have a colleague who's working in Google training. He's just training Google for as far as English and Japanese, because those are his specialties. I have to ask him if they're training Google speech with Filipino. Most likely they have Filipino training with the machine language. So I hope you answer that question.
Okay, next. Do you consider Canvas an awesome technology spurred by the pandemic? It seems like some of the teachers are having difficulties with Canvas.
Okay, awesome technology. Well, I'm not really awed by it. Of course, um, first of all, it's the only platform that I know aside from Google Classroom. School, was it again? Schoology, I think. In terms of UI, they say it's better, and in terms of workflow, it has some additional points over Canvas. At least it's good because now it really enables the Canvas and all of these learning management platforms enables online learning, and there are things that can be done online, and you don't have to go to school in order to do them. You can think, for example, multiple choice questions and stuff like that. Of course, you have other things like the essays and stuff like that. So Google, for example, has been pushing their virtual learning environments for that. And even, for example, auto detecting copyright issues and stuff like that. It seems some the teachers are having difficulties with Canvas. Yes, as with any platform, there's always a learning curve. And of course, that any platform is not perfect. So no software or application is in its final phase. So I agree with you. I hope that I answer your question.
Okay, next question. Cool presentation. I was
Thank you.
amazed about the voice frequencies. Won't that be a potential source of discrimination due to gender?
Due to source of discrimination due to gender. Yes, I mean we humans. I mean end up modeling things. I mean we figure out patterns because of it. In fact, this is good because when hey, there's a child there because it's crying with this high pitched voice. If it's crying with this low pitch, then probably it's an older person. So it's pretty normal. It's okay. This is because we humans are trained. We train our brains for profiling. It's good for us because that's how we learn. That's how we do things. We mix and match things. So I would say it's pretty normal. So if it's a matter of discrimination due to gender, so if a person would be talking in a high pitch, I would say that. So the frequency range that I showed you is based on the average. Okay, so typical male, typical female, typical child. Of course, will always have in any environment. You will always have the outliers, and of course, we don't discriminate the outliers. Of course, the bad thing there is when you really start. I mean, the moral issues. No, so for example, when people are hurt because of those decisions that you make, they become outcasts because of your actions. But again, it's okay because these are just averages. These are just like patterns that we understand in order to understand ourselves better. But it already depends on the person if the person would really discriminate based on these profiles. I hope I answered that question or if it's clear enough.
Okay, last question. Is
Oh.
reducing noise possible in Canvas Big Blue Button?
Canvas big blue button. First of all, what is Canvas big blue button? I don't know what Canvas big blue button is. Kindly enlighten me. I'm sorry, I can Google it now. Canvas big. What's Canvas big blue button? Does anyone know? Doc Vec. I don't know if Doc Vec is still around. Big blue button. Canvas big blue button. Okay. Sorry, I don't know what Canvas big blue button. So it's in an integration. Well, the answer, quick answers, just I don't know. First of all, what big blue button is. If this thing is open source or if it's extensible, then I suppose because all of these, for example, you can go to Google and then this thing of TensorFlow. These technologies here, they have all the libraries. It has a complete set of libraries. It's an TensorFlow is an end-to-end open source machine learning platform, by the way, and software library. So you can find if Big Blue Button is extensible, then you can always introduce some of these technologies from TensorFlow to Google TensorFlow. Because it has a flexible ecosystem of tools, libraries, and even community resources. But I don't know exactly if it's possible, but I think it is possible depending on the extensibility of the platform. I hope I answered your question. I hope you're still around to listen to it. It's on a conference of Canvas for video. I'll look into that further. But this is the first time I've heard of Big Blue Button. I'm sorry about that.
All right.
It says here it's an open source project. So if it's an open source project, then definitely it can be extended. Yeah. So it's very, very possible. Because these are just the noise reduction in Google. The libraries are available. Yeah, so I hope I answered all your questions.
All right. I think that's all for the Q&A portion. And if you have any more questions, you may contact Sir Joel Mendoza. And so that concludes our brown bag session for today. We would like to thank Mr. Joel Mendoza for that very informative talk. And of course, thank you everyone who joined us for today. We're hoping to see you guys again on the following sessions, so stay tuned. Thank you and have a great day, everyone.
Thank you.